Today we discuss about ASP.NET Core database connection, and for this we will use Entity Framework Core. First, some more words about Object-Relational Mapping, or shortly ORM. It's a programming technique used to convert data between incompatible system types using object-oriented programming languages. So basically we can convert from one language to another. In our case, we will use ORM to convert from C# to SQL code. Entity Framework is an open source object relational mapper that allows .NET programmers to interact with the database using .NET objects. This eliminates the need to write data access code that programmers usually have to write. So basically, using Entity Framework, we can convert from .NET code into SQL. This allows developers to work with data that uses domain objects without focusing on the tables and the columns in the database where this data is stored. So basically we can work at a higher level of abstraction and we don't have to care about the tables or the columns in the database. We just interact with some C# objects. So basically we work at a higher level of abstraction when using data, and we can create and maintain applications with less code compared to the traditional applications. Entity Framework links domain classes and the database. Let's take a look on the right in figure 1, okay? So, suppose we have a... Și până acum și-a dat nimeni seama. I was saying that Entity Framework link... Yeah, of course, it's also mentioned on the slide. So basically we have 4 main operations that we typically perform in a web app. Create, okay, inserting data, read, okay, reading data, update, modifying data, and delete, removing data from the database. The first step to integrate CRUD operations is defining the model, okay? And defining the model means if we take a look into this schema, the first step is defining the domain classes, creating the context class, and additionally defining some configurations, okay? Now let's take a look into each operation. The first one, inserting new data into the database, okay? Basically the insert operation or create. Let's look at step 2. Suppose that we have an HTML page with a form. This form is used to specify some details about a product that we want to save into the database, okay? So the user fills in these fields, okay, and then presses a button to save the product into the database. What happens? When the user presses that button, actually, Entity Framework will make these 2 calls, okay? We have this add entity object. Entity object is actually an object that stores the information the user filled in the form, okay? So basically here we store the data that was entered by the user. We add this object to the context, and then we execute save changes on the context instance. Save changes means that we want to save the changes, the new object that we added to the context, we want to save it on the database. Behind the scenes, Entity Framework will build and execute an insert command, okay, because we add the new entity to the context, and we'll execute that command on the database. In the end, we will have the new object into the database, okay? Now, let's move on to read operation, reading data from the database. We are at step 3. Suppose again that we are on a page and we want to visualize information about a product. The product is stored in a database. How can we do that? We can execute a C# LINQ query, okay? That C# LINQ query will be converted by Entity Framework into a SQL query of type select star from table and so on. The SQL query will be executed on the database, The database will return maybe some results. The results will be in a SQL format. Entity framework will transform those results from SQL into C# entity objects, okay? So basically entity framework takes care converting between C# and SQL code in this case. And in the end, we can use those C# entity objects in order to display information to the user about the product. The last two operations are change and delete data from the database, okay? So update and delete operations. To change or delete data, the objects must be changed or deleted from the context, and the method save changes must be executed. Let's take a look at step 4, okay? Maybe we have again a form on a page, and we want to change some details about the product. Okay, so, or maybe we want to delete the product. Maybe the user presses a button and wants to delete that product. What does it happen? Basically, if we want to modify the object, we call update method on the context instance, sending the entity object, okay, with the new values. Or if we want to delete the object from the database, we can execute remove method on the context, again passing in the object that we want to delete. In the end, we execute save changes on the context. Behind the scenes entity framework will infer, okay, the update or delete commands based on the changes that we have done on the context instance. It will execute these commands on the database, and in the end, maybe we get some results back. Now, let's see the querying operation. We said before that entity framework and the API translates C# linQ queries into SQL queries and converts the results back into C# entities. Let's check figure 3. Okay, on the left, the first line builds or creates an object of type school context. On the following line, we have a C# linQ query. Okay, this is a C# query. Notice that it's similar with the SQL code. From S in context.students, where S.firstname equals Bill, select S to list. Basically, here we select from the list of students. The list of students is available using the context instance. The ones that have as first name Bill. Okay. When we execute this C# query, entity framework will translate it to SQL code and execute it on the database. So the resulting SQL query will be like this one. Select star from students where first name equals Bill. Okay. The database will return maybe some results, maybe no results if there are no students with this first name. And it will transform the results from SQL into C# entity objects. Okay. And these results, we can assign them to the variable students, okay? Yeah, the other main operation is saving into the database. Entity framework API infers the commands insert, update, or delete, depending on the state of the entities when we execute the method save changes. So when we execute this save changes method, what happens? Entity framework API takes a look into the tracks changes module. This module, as we said before, keeps track of all the changes that we have done on the entities. Okay, maybe we have changed the property of an entity. Okay, or maybe we have deleted some entity from the context. Okay, it keeps track of all the changes that we have done on the entities. Based on these changes, entity framework will build and execute insert, update, or delete commands. And in the end, these commands get executed onto the database. Now, the context class. It's an important class used to query or save data to the database, as we have seen earlier. It is also used to configure domain classes, to define track changes settings, for caching, defining how transactions work, and so on. Let's take a look on the right. Here we have the class school context. Notice that it inherits from DbContext. Okay, it's very important, this step. We have a constructor which is empty, and then 3 fields. Okay, 3 public fields. public students, public student addresses, and public grades. These fields are called in C# properties. What are properties? Are these fields that we can get or set values for them. An entity in entity framework is an application class that is included in the form of a property of type DbCent in the context class. So basically, here we have how many entities? Which, yeah, let me see which is the fourth one. So we have students, student addresses, and grades. Okay. Okay. So an entity is again included in the form of a property of type DbCent in the context class. Now, an important aspect, okay, remember this, entity framework maps each entity to a table and each property of an entity to a column in the database. So again, how many tables based on these entities we will have in the database? Exactly, it's a simple question. So for each entity that we have here in the context, we will have a table. We have the table students, student addresses, and grades. Here we have some examples of domain classes or entities for an application that deals with student management. Okay, it's a simple application with 3 entities: student, student address, and grade. Okay, student address describes the address of a student, and grade describes the grade the student has. Notice that every entity has some properties. Yeah, student has the properties student ID, student name, date of birth, and so on. The entity student address has a student ID, address 1, address 2, and so on. Okay. The classes presented become entities when they are included as properties of type DbCent in a context class. Okay, like we have seen earlier. Now, some aspects regarding terminology. The properties students, student addresses, and grades of type DbCent are called entity sets, while the classes student, student address, and grade are called entity types. Now, an entity may include 2 types of properties. We can have scalar properties or navigation properties. And it's important to remember, okay, this. Primitive properties are called scalar properties. They store the actual data and are mapped to a single column in the table in the database, okay? So for each scalar property or primitive property, we have a column in a table in the database. Let's take a look here in figure 7. So for each entity, we have some rectangles, yeah? We have a red rectangle and a green rectangle. In the red rectangle, we have the scalar properties or primitive properties. Primitive properties because they use primitive data types like int, string, datetime, byte, decimal, or float, okay? And we said that for each scalar property, we get a column into the database. So can anyone say for a student which are the columns for the student table? Some examples of columns that we have in the students table. No. Can you say again? So yeah, what are the columns of the students table? So the columns of the students table will be like student ID, student name, date of birth, photo, okay? So those primitive types represent columns into the database. For the grades table, what are the columns? So we have the columns, yes, grade ID, grade name, and section. Yeah, for each primitive type, we have a column. We can also have navigation properties. they represent a relation to another entity. Okay, so basically we can have relationship between one table and another. There are two types of navigation properties: reference navigation and collection navigation. When an entity includes a property of type entity, it is called reference navigation property and represents a multiplicity of 1. When we have an entity that includes a property of type collection, it is called collection navigation property and represents a multiplicity of 1 to many. Okay, so yeah, we can have different relationship between entities. We can have one-to-one. Okay, for instance, in this example, a student can live at an address, and at an address can live only one student. Okay, so this is a relationship one-to-one between student and address. But we can also have like one-to-many. Okay, can you give an example? Yeah, a school can have like yeah, students, or students I think it's called. Yeah, so a school can have many students and a student can attend a school. Yeah, so we have one to many. And we can also have like many to many. For instance, maybe like the relationship between like students and courses, like at a course can attend more students and one student can attend more courses. Okay, so this is the relationship many to many. If we take a look here in figure 7 again, in the green rectangles, we can see these navigation properties. For instance, a student has an address and a grade, okay? In this example, a student can have only one grade. In real life, yeah, it can have more. Okay, and the grade can have more students. Yeah, here we have a collection of students, the list of students that got that grade. So this is a collection navigation property. We can access all the students that received a particular grade. Now, let's move to development with Entity Framework Core. There are two different approaches that programmers can follow when developing an application using Entity Framework Core, okay? One is called code first, and the other one is database first. Code first, okay? Here the entities or domain classes and the context class are created by the programmer. So basically you have to type the code, you have to write the classes for the entities and the context class, and you will see immediately an example. The database is generated using migration commands based on the entities and the context class that we have created, okay? Let's take a look in figure 8. We define the domain classes, okay? The entities and the context class. We run some commands, entity framework creates a migration, we execute it, and we get the database. Okay, so based on the classes that we define in the application, we get the database. This approach is used when there is no existing database for the web application prior to the development. The second approach, yeah, database first. Here the entities and the context class for the existing database are generated by executing entity framework commands. So basically we don't have to write the code. Entity framework, based on some commands, will create those classes for us. So if we take a look in the figure 9, we have a database, we run some commands, and entity framework creates the entities and the context class, yeah? This approach is used when there is an existing database for the web application prior to the development. And now let's create our first entity framework core application. I've already done this actually. You can find on GitHub an example. Yeah, so if you go on GitHub, you can find here lab 5, ASP.NET Core EF Core App. Inside this one, it's the application that you can use. In order to create a new application, it's quite simple. Like we go to File, New, in Visual Studio, Project Solution. We select the template ASP.NET Core Web App. We make sure that we select Model View Controller template. Next, we enter a project name and a location for the solution. We select a framework, okay, .NET 10 in our case. We leave the rest of the fields like they are, and then we press create. In that moment, Visual Studio will create the solution for us. In order to integrate Entity Framework Core, we need to include some packages using Nugget. Okay. To include packages using Nugget, we have to go to Tools, Nugget Package Manager, and Manage Nugget Packages for Solution. Okay, we wait a second, and here we can search for packages that we want to install in our app. I have already done this. You can find them in the tab Installed. You need to install 3 packages: Microsoft Entity Framework Core, Microsoft Entity Framework Core SQL Server, and Microsoft Entity Framework Core Tools. Okay. In case we want to use a different provider, different from SQL, we have to install a package for the database provider that we want to use. But as we are using SQL in this lab, it's not necessary to include other packages. The first step, to provide the support for CRUD operations using Entity Framework is to define the model, okay? That is, the entities and the context class that represent the model must be defined. These entities and the context class must be added to the models folder. Okay. Let's suppose that we want to build an application for blogging. Okay, it's a simple application where we have 2 entities. We have entity blog and entity post. A blog can have a blog ID, okay, a primary key used to identify the blog, a URL, and a collection of posts on that blog. On the other hand, a post can have a post ID, okay, used to identify a post, a title, a content, an external key to the blog that we want to add the post, and a navigation property to the blog where the post was added. If we go to the solution now in the models folder, you will see that we already have those 2 entities. We have blog and post, exactly as they are on the slide. Yeah. Next, we have to define the context class. It's called blogging context. It inherits from DbContext. It has this constructor, and it provides two properties. These are actually the entities that we are working with. The 2 entities, they are included as DB sets. We have blogs and posts. Again, if we go to the models folder, you will find there the blogging context class. The next step is registering the context using dependency injection. The context class must be registered as a service in the program class in order to be accessed in the MVC controllers. And we will discuss more about accessing services in controllers in a future lab. The services such as blogging context are registered using dependency injection when the application starts in the program class, so that they can be offered automatically to the components that use these services, like the MVC controllers. Most database providers require some form of connection string to connect to the database. Okay, so basically the connection string takes care of defining the connection to the database. Sometimes this connection string contains sensitive information that needs to be protected. Okay, we don't want anyone to know the database that we are connecting to. In ASP.NET Core, the configuration system is flexible and the connection string can be stored in app settings file, in an environment variable, the user secret store, or another configuration source. In our case, we will store this connection string in the app settings file. It contains several parts. The server, which represents the name of the server where the database is located. Database, which is the name of the database that we want to connect to. Trusted connection, which specifies the authentication mode for the server. And connect retry count, which defines the number of reconnections attempted after identifying that there was an idle connection. Okay, so now let's see the two steps required to register the context. The first one is defining the connection string in the app settings file. And if we go now in that file, you will see here from line 8 to line 9 and 10 that we have this connection string called bloggingdb. Yeah, and this contains several parts. The name of the server that we want to connect to, it's a local instance integrated into Visual Studio. The name of the database, I suggest for you, of course, to use a good name for the database when you create the project. And the other two, okay, two settings that are not very important. After we have defined the connection string, the next step is to register the blogging context class as a service. We go to the program class, and here on line 8, we have this call, add DbContext. Yeah, this one registers the context, blogging context. And yeah, for this we have to send the connection string. Now, in order to create the database, we have to create a migration. Creating a migration is quite easy. We have to go to Tools, Nugget Package Manager, and select Package Manager Console. To create a migration, we have to run the command apt migration, passing in the name of the migration that we want to create. The name, it's okay, it's your choice. In this case, the name is initial create. After running this command, you will notice that a new folder will be added to your project, a folder called migrations. Inside this folder, migrations, are two files. The one with the migration that you have just created, and another one, it's a snapshot from Entity Framework that we will not take care of now. But if we check the migration file, you'll notice it has two methods called up and down. And in the app, yeah, we have some calls, create table. These calls create the tables, of course, in the database. This one creates table blogs, and this one creates table posts. Notice again that here we have defined the columns. For the blogs, we have the columns blog ID and URL. And for the posts, we have the column post ID, title, content, and blog ID. We also have defined some constraints, the primary key, and for the post table, we have also a foreign key. An index was also added to increase the speed for retrieving the data. And after we have added this migration, the last thing is to run the command update database. After running update database, basically the migration gets executed and we have the database. How can we visualize the database? In order to visualize the database, we go to Tools, connect to Database. We enter the name of the server, the one we specified in the connection string. We select from this drop-down the database we want to connect to. We press OK, and on the left, in Server Explorer, we get the database and the tables. We have 3 tables. One was automatically created by Entity Framework, this one, EF Migrations History. And the other tools that we have defined, blogs and posts. Blogs has the columns blog ID and URL, and posts has the columns post ID, title, content, blog ID. Okay, so notice the match between the models, okay, between these properties on the models and the columns. These two properties correspond to these two columns, okay. We can also create a controller if we want to check the connection with the database. We can add a controller supporting CRUD operations. How can we do that? We right click on the controllers folder, select add controller, MVC controller with views using Entity Framework, and then press add. In the new window, we have to select the model class. We have two models, blog and post. Okay, a controller name is automatically set, and then we can press add. I have already added a controller for blogs, and yeah, here we have CRUD operations automatically added by entity framework. We have different actions like index, details, create, edit, and for each action we have a corresponding view in the views folder. We have here the create view, delete, details. Basically, these are pages into the application. Let's run the application now. And now we can navigate to blogs. Okay, this is the index page. Now we don't have any entries. We can create one by pressing this link. Let's define a URL, press create. The blog is created. We can see details about the blog. We can edit details. We can save them, or we can delete them. Okay, so these are the CRUD operations for the blogs. They were automatically added by entity framework. Yeah, here on slide 29 and 30, you have some practice tasks that you can work on. The first one is to add comments, define one-to-many relationship. The second one is to add authors and define many-to-many relationship. And here you can find some additional resources if you want to study about lambda expressions or LINQ queries.